Hi, everybody. My name is Azzam. I work at a company called Prefect. And today I'm going to talk a little bit about what works in production in productionalizing the model context protocol, and really just trying to understand like kind of what still breaks, what's underdeveloped, and kind of why. So I'm not going to assume a lot of knowledge about the model context protocol. I'm going to talk about like what it is, where it came from, what its original design goal was, and why the dogma of that design goal is still kind of making it hard to go to production for some teams. And for some of those that have, how have they maybe departed from the protocol, or what parts of it have they embraced more than others? And so maybe just kind of zooming out a bit. So about 8 months ago, MCP arrived with a pretty simple promise. It was supposed to be a standard way for AI systems to connect to any data source. And since then, MCP servers have started like basically becoming this connective tissue between large language models and the data that they depend on. So I've been building FastMCP alongside Jeremiah Lowen, and really FastMCP is becoming like really, if you've written an MCP server in Python, you've likely written it with FastMCP. And so we've had a chance to really peek inside of thousands of teams who have basically been like, hey, this thing is broken, can you come and fix this thing? And then we'll have a conversation with the team. And so this is like just basically a lot of lessons that we've learned from talking with so many teams getting these into production. And so maybe where I should start is, let me talk about like what is Prefect. So before we dive into MCP, let me explain what Prefect does. Prefect's a workflow orchestration platform. We help teams build, run, and observe data pipelines. And we've been pretty obsessed with making complex orchestration feel like writing simple Python code. So I don't know if you folks have ever written like Airflow code before. You basically have to go study Airflow for a long time before you can get something to work. Really, our design philosophy was like, what if you just take Python that people normally want to write, take it as a constraint that they don't want to refactor their code? How do you make orchestration work? And so really just have kind of been obsessed with how do we make really complex things like standing up an MCP server or doing workflow orchestration feel simple with code that people already have. So today, Prefect, we orchestrate literally like a millennia of compute every month. And why that matters for this story here is before MCP arrived, we really were kind of at the forefront of agent orchestration, because teams that were really trying to bridge like how agents are talking to data. We're trying to find orchestrators that could work for both their agents and their data pipeline. So as teams started wiring these things together, it turned out that they needed a dynamic orchestrator. And so that's why they came to Prefect. So when MCP was introduced, it really formalized something that we've been seeing in practice, that the challenge wasn't really just calling a model, it was giving the model the right context, the right tools, the right coordination to get stuff done. And so FastMCP is really our response to that. It's trying to bring everything that we've learned about turning simple Python into production-grade distributed systems, and it applies to this sort of emerging infrastructure. So this is really what writing and workflows in Prefect really feels like. But this is not a Prefect talk. Just trying to give to kind of zoom out and give a little bit of context of like who we are as a company and why we find this problem interesting and how we found ourselves in it. I should probably also tell you a bit about who I am. This is like kind of an appeal to authority bias, like why on earth would you ever want to listen to me? I'm VP of product at Prefect. I span across our engineering and product teams, have been in this space for a while. Before this, I was a Prefect user. I used Prefect at my previous startup, where I was CTO. I was orchestrating millions of LLM calls, trying to build agents for job seekers, to do job searches for them latently kind of in the background. And so I chose Prefect as an orchestrator, went to their founders saying like, here's all this stuff that if you could just build it, you could make orchestrating my agents a lot simpler. And they were like, cool, let's collaborate on it. And then that collaboration inevitably turned into me joining their team. So you can find me on the internet at AAAZZAM. I've done a pretty good job of squatting on that handle pretty much wherever. Okay, so what is FastMCP? So FastMCP was really our answer to a pretty simple question. I don't know how many folks saw the original Python SDK for building MCP servers. it was really difficult to build with. I remember the Thursday or something that it came out, Jeremiah, the founder of Prefect, and I sat down and we're like, one, we don't really understand the value this has over like a REST API. We were still wrapping our head around it. And then on top of that, it felt like a nightmare to actually write. And so we were really craving more of like a fast API style developer experience for building MCP servers. And really what Anthropic put out at the beginning was more like Starlet in this analogy. And so when Anthropic released MCP in November 2024, we saw this gap that like the reference implementations were more like educational, but they weren't really helpful for people getting stood up in production. And so like a week after they put it out, we spent a very long weekend building FastMCP. And since then, it's really become the Python foundation that most MCP servers are built with. Anthropic, about a week later, approached us to incorporate our 1.0 code into their reference implementation. So today, basically, if you're building an MCP server in Python, you're either implementing our 8-month-old snapshot from the official SDK that they've adopted, or you're on FastMCP 2.0 that we actively maintain. And so maybe just to give you a sense of what this looks like is like, you might be more familiar with this interface is like really trying to make sure that, you know, a single decorator can take a Python function and turn it into a production-ready MCP tool. We're really like just trying to make sure that the interface is simple and taking care of a lot of the complexity behind the scenes. We saw a lot of developers struggling with the complexity of the protocol, even in that first week. There was just basically a big group chat where people are trying to figure out how to get this thing to work. And you know, basically after reading the encyclopedia, that was the reference spec, we couldn't figure it out. And so we set out to build something similar. And so really, I think what I'm hoping to accomplish today is to talk a little bit about like, you know, what's the actual original motivation for MCP, and what are some of the problems that people have come up as they've been trying to implement it. So let me try to paint a picture of the problem that MCP solves. So AI assistants have obviously made pretty incredible gains in reasoning, but they're still fundamentally disconnected from the data that they need. And so I don't know how many folks in this room have the like distinct displeasure of like, if you want your assistant to check Salesforce, you have to build a custom connector. If you want to pull it from your data warehouse, you have to build another connector. And so each integration meant more code to maintain and meant more security reviews, more breaking changes. And honestly, that didn't scale. So MCP was Anthropic's answer. It was the standard for linking AI systems to any data source by letting models pull fresh information iteratively until they reach an answer. And I think what was crucial about what the team at Anthropic noticed was like REST APIs and open API specs that you know you can generate from them were great for human developers, but they were pretty terrible for agents. There were too many endpoints. There was too much choice. And that choice really ended up polluting the context window to where like agents really couldn't reason over like a large API spec. And so agents really needed something different. They needed something that was carefully curated. They needed something where they could easily digest what tools they could actually use and not like try to figure out, okay, which methods in this spec are actually like calling out to file systems, which endpoints in this spec are actually for like invoking remote procedure calls, and which ones of these are like really for just like formatting how answers are supposed to come back to me. And so that was a distinct problem that MCP was trying to solve. And so it was really this separation of agent and tool. So from a developer tools perspective, it's a pretty big shift, right? So in the early days of agent development, most tools would live right alongside the agent. You would like import them in code. You would slap them right aside your agent. So like function calls, you would have in-memory chains. You'd have these handcrafted integrations and work for demos. And I think as teams pushed agents forward towards real production environments, that tight coupling became a real bottleneck. And so you couldn't really scale, reuse, or observe your tools easily across use cases. Like you'd have like, you know, the world's most sprawly monolith, but it made it really hard to like share tools between teams. And so people started like, of course, decoupling those tools from agents behind like HTTP endpoints and APIs, and tools ended up becoming this thin wraparound APIs. And so every organization would try designing APIs that would wrap tools that you could invoke remotely, and then they would have to agree on what those shapes of those tool specs would have to look like. And so I think Anthropic just saw that story happen over and over, where they were like, well, look, we can actually just define the standard for this, and then people can coalesce around it. I'm going to be honest, I didn't see the promise of MCP very much at the start. I thought when I first thought about building an MCP server for Prefect, it kind of looked like this novelty, like, great, it's just another way to like chat with X. But the more that I talked to our users who were like, saw that, we held a lot of context as an orchestrator that people were trying to consume, and it was one constituent of a larger workflow that they were trying to orchestrate. I understood that, like, basically we had to find a way of exposing ourselves as a tool that that people could plug in as context to their agents or their more like LLM driven workflows. And so who's building with FastMCP today? Basically everybody. So when we released FastMCP, honestly, we hoped it would be useful. It was definitely useful for us. We didn't expect it to become the standard in Python. So honestly, we've been pretty blown away by the response. And so, I think for me, the logos matter less than kind of what they represent. Honestly, the path from simple Python code to this like robust production system should be obvious and reliable. And so it's been really great to see the adoption of FastMCP. Okay, so that's like a little bit of background on like what's MCP, what's FastMCP. But honestly, this talk is not like an infomercial for a particular library. This is what I want people to walk away with is like, if you're building this yourself, no matter what framework you use, what are actual like lessons that we've learned working with a lot of teams around this. And so the kind of why behind this is trying to, it's been out for about 8 months, and so early adopters have built their servers, the protocols are still stabilizing, but there's still this kind of gap between, I can set up a thing that works with Claude Desktop that's like npx runs some CLI command, and that's different from like I've built a remote MCP server that can handle traffic from users. And so this talk is really about that gap. And so I'd say that what we've learned is that teams kind of face two distinct types of challenges. What I'm going to call protocol problems. Those are issues with MCP itself, and product problems. This is like people adopting to a new way of serving context and then kind of falling on their face around it. And so one makes it hard to implement, and then one is, if you've implemented, it makes it hard to be useful. And so I want to talk about like, what are things that people have done to make this easier to implement? And then once they're past those barriers, what are the things that they've done to actually make this useful to people? And so I would say that, these problems fall into two categories. As I said, like protocol problems, there are fundamental limitations in how MCP was originally designed. If you go back to the original documentation, MCP was built for a very specific use case. It was standard I/O communication between a single desktop Claude app and local tools. There was one client, there was one server, it was a stateful connection, you had this perfect isolation, and it was beautiful for that use case, but of course it was not particularly well developed for like, great, now I want to build an MCP server and I want to go sell it or sell access to it. Or I have an app that's normally served behind an API, I want to build an interface that's easy for an agent to consume, but now I'm going to have thousands of people consuming the same resource at the same time. And then the second piece is I'm going to say around product problems, which is like, I think that for folks that are like, nihilistic is the wrong word. For folks that are like, yeah, MCP just kind of feels like a hypey interface, like it's probably just as good as a typical REST spec or something like this. Those people tend to have the most problems actually building useful MCP servers, because I think that it requires a bit of a departure from how we've thought about exposing context before in order to build something useful, because fundamentally you're building for a different type of user. So MCP's original design, as I mentioned, can tell you everything about the problems that we're eventually going to face. It was built for standard input-output streams. So when Claude on your desktop wants to use a tool, it will literally spawn a subprocess. It maintains a persistent bidirectional connection, and it assumes total isolation, which is beautiful for local development. But this design kind of embedded assumptions that would haunt everybody as they tried to share these things remotely with folks. So like, if you have thousands of servers, if you have thousands of clients trying to access a server, how do you build this in a serverless thing? Like we spent the last decade trying to advance serverless compute so that you can like auto scale with respect to usage demands. But now if you have stateful sessions where like the literal runtime has to hold on to the information about the session, but your load balancer doesn't know about it, then basically a new request will come in for the traffic to another container, and then that container is like, I have no idea who you are, and then your connection will fail. And so honestly, like I'm not knocking Anthropic. I think that these weren't really oversights. I think these were super reasonable choices for the original use case. And I think that like as teams started to go beyond localhost, each assumption kind of became a barrier. And to their credit, they've been really trying to fix this and evolve it. So let's talk about one of these first barriers. So let me talk to you about transports. So when teams first tried to move MCP like off of standard I/O, the obvious choice for bidirectional communication was like WebSockets or server sent events. And so just to keep that stable connection just over the network. But what actually would happen is like you would deploy your MCP server on like, I don't know, like ECS or Fargate or Kubernetes or something like this with multiple pods, because you wouldn't have multiple pods for high availability. And so a client would like connect to pod 1, but subsequent requests would get round robin to pods 2, 3, and 4. The connection would get lost, the state would be gone, the client would get confused. And so that auto scaling story, or like even just like if you hold your resources fixed, but you're trying to build something high available with high availability, WebSockets and SSE, like you can, I'm sure there's somebody in this room who can architect a system to make it work. But for a lot of teams, it was very hard to get that to work. And I think classical deployment paradigms that we've gotten used to. And so the community really converged on streamable HTTP as this pragmatic solution. It's stateless by default. You can opt into streaming for long-running operations. You can opt into SSE if you'd like. It's not really as elegant as pure WebSockets, but it works in production. So it's really like, I think the pragmatic option here. And so I think one of the big lessons here is like, you saw a lot of early adopters build on SSE. A lot of those early adopters are ditching SSE for streamable HTTP. The MCP steering committee itself is basically like, I think they've declared that they're not going to support WebSockets anymore. And a lot of the discussion is around like, I think the time for SSE is limited or is short. And so if you're building an MCP server today, would really save yourself a lot of headaches and just build on streamable HTTP. I would say the second big bottleneck that you have to overcome just sort of around a design choice of original MCP was it was originally designed for a single user talking to their own tools. It was this like one-to-one model between a client and a server. But of course, like if you actually want to take this to production, MCP servers are serving thousands of users, each with different identities, roles, quotas, and access. And so that really breaks the assumption that was built into the original design. And so the early auth discussions in MCP were really cool. At first, I think a lot of folks assumed that the OAuth client credentials would be enough. The MCP client would authenticate to the server and you're done. But that only tells you which client's making the call. It doesn't really say about like who the client is acting on the behalf of, and that distinction really mattered. And so, why the community really pushed against this was like, look, we already have pretty robust authorization servers that have and hold on to identity. Really, the right way to do this is to treat MCP as a resource server where, you're delegating authorization out to like, Work OS, or you're delegating it out to Stitch, or you're delegating it out to like your own, I don't know, like Okta for your company or something like that. Whereas you can delegate this MCP server as like, as we're not gonna be responsible for authorization, for authentication, but we can play some role in authorization and trying to figure out. Sorry, I think I flipped that. Is that we're not going to take on an authorization responsibility. We're going to really just try and figure out like, who has access to what resources given their trusted claim that comes from an upstream identity provider. And so in OAuth terms, the authorization server is going to be responsible for authenticating users and issuing access tokens. And this resource server is responsible for validating those tokens, enforcing access control. And so people really push for this because it was pretty critical in multi-tenant systems, because it allows one system, the auth server, to maintain the source of truth and identity and policy, while another, the resource server, is sort of enforcing it dynamically at runtime. And so this was like just, this is, I think in the last month, I think it came out June 28th or June 16th or something like this. You can still find a ton of documentation that tells you how to like, that tells people how to set this up as an authorization server. I would just say like ditch that out of the gate and just try and treat this as an OAuth resource server out of the gate. And so it's just going to save a lot of headache, because it's going to allow you to piggyback off of your like kind of existing auth setup. I would say the next piece of like moving from local to production is, MCP is pretty feature rich, but a lot of those features depend on having stateful connections. And I think stateful connections, as we talked a little bit about before when we talked about transports, made a ton of sense in, when you had one client, one server, you could maintain a long-lived connection forever. But of course, the problem is in most deployment paradigms, you can't really control which traffic is going to which container. Like obviously, if you put in enough effort, you really can, but by default, this is hard to configure. And so it ended up just tripping up a lot of teams who are used to just being able to deploy between something Kubernetes or Kubernetes adjacent. And so really a lot of teams are dropping the statefulness assumption and pushing it in stateless mode. And so stateless is honestly winning almost every time, because of serverless platforms like Lambda, Cloudflare workers, Vercel edge functions. These are things where people are used to deploying to. They're cheap, they scale automatically, and they're fundamentally stateless. I think Cloudflare has some workarounds where like you can have distributed objects that are tied to the life cycle of your server, so you can persist state. But statefulness also just contributes a ton towards like making it like, I think in the actual implementation, and it depends on which language you're in, like session state is handled completely in memory. So if you have like thousands of people all trying to have a stateful connection to a server, you start having like random out of memory problems. And so like my recommendation here of going stateless may change, I think, as the MCP spec becomes more intentional or more prescriptive about like how to persist sessions remotely. But at the moment, it's just pretty brittle, and a lot of the things that basically cause people to have to opt out of, or sorry, like the biggest things that cause MCP servers to fail in production is just like you test a bunch of stateful things locally, and then stuff just fails over because you're persisting a lot of stuff in memory for sessions. I realize I'm running out of time, so let me skip my observability slide and just say like, those were some of the bigger like spec problems just around auth, around transport, and around statefulness. Maybe what I'll say about like some of the product problems is, I think one of the most common mistake I see, it drives me crazy, is like teams that are wrapping their 500 endpoint REST API, wrapping it in MCP and calling it done. And it's like, look, AI can now use our API. It tends to make everything worse. So this is probably one of the biggest product problems that I see people face, where like they get around all of the actual spec problems, they deploy something, and then agents just can't really do their job. And it's because that 500 endpoint API is now just like a 50,000 token tax on every interaction. And a lot of your API methods were actually designed for like discoverability, where I think the name of the game is curation, right? So REST API is optimized for humans, and those tend to be terrible for agents. And so, I would say like the biggest piece of advice that I've had teams give me of like, that they've had to totally revisit is throwing away, frankly, like their entire REST API spec and starting from scratch and being like, great, what's the actual functionality that we want to enable, and then carefully curating all the context that an agent needs in order to do that limited scope of jobs. And I think that just taking an open API spec and trying to convert it into an MCP server is just like such a great way to make an agent just kind of fail miserably. And so that point broadly is just like, I think that in API design in the beginning, we've designed almost entirely around discoverability. And so you just add more endpoints, you add more parameters, you add more flexibility. You know, you're trying to make an a la carte experience for humans who you can depend on to like read your REST API spec, you know, filter pretty nicely for the functionality that they're trying to assume, or they're trying to get access to. But agents don't do that, or they don't do it very well. So every time you make a new optional parameter for human developers, that's nice for them. You're actually hurting agent performance. You're increasing the decision space by another factor, and so it can make it really, really difficult for agents to reason over what they're trying to do. And so instead of being like, here are all the 500 tools, I think it tends to be more like, here are the 5 tools that are relevant to your current task. And instead of saying this parameter accepts 20 options, it's more like, you know, either question or hide that parameter to begin with, or, you know, choosing really smart defaults for it or something like that. And so I am a minute over time, and maybe 70% of the way through. So what I'm going to do is I'm going to pause. I'm going to make sure that these slides are shared after the fact. I'm going to take a brief look at Q&A. I think I've answered some of this as we've gone through, but I'll say that, like, to answer Raj's question, I definitely see MCP evolving into a standard across providers. You know, in the last 2 months, you've seen Microsoft, Google, OpenAI, all like ostensibly competitors to Anthropic, say like, great, this makes total sense to us. Having a common format for agents to understand the tools that they need to consume makes a ton of sense. And we're happy to coalesce around it. And so I would argue that it's already become a standard. I think that what folks really haven't cracked yet is how to design an MCP server that that can enable as much functionality as your canonical REST API built for a human is. And so I'm excited to see sort of how teams continue to actually build useful MCP servers. I think a lot of people are just trying to put AI on their roadmap, so they wrap their REST API in an MCP server and call it done. And then I would say Anonymous's question of how do MCP-based servers typically interface with existing data governance or compliance pipelines. I think that's where auth comes in. So like, you know, maybe I'll say that like observability is still an unsolved problem for MCP servers. There's not like open telemetry for it that's natively built. And so what I've seen along these lines is like you can grant specific scopes and you can log like which tools have access to what systems. That exists natively in FastMCP today. And then you can grant specific tools that have specific scopes. You can grant users with scopes access to complementary tools. And so that's one way that you can enforce data governance or compliance, where you can say like, these users that I know the identity of have access to these scopes have access to these tools, and then you can log which invocations of what tools are actually done as a way of tracking compliance or data governance. So, okay, so I'm gonna cut myself off. Hopefully this was helpful. I'm happy to share some of these slides afterwards to be able to see like some of the stuff that we weren't able to talk about, but managed to get through some of the bigger obstacles that people face getting MCP servers into production. So maybe I'll skip to the very end and say, you know, you can follow us on X or Blue Sky at Prefect.io and me at Azzam. We're building FastMCP Cloud, so go check us out at fastmcp.cloud. We're hiring for it, and so if you really want to be a part about, you know, how do you make it incredibly trivial for developers to build, deploy, distribute, and monetize MCP servers, drop us a line. All right, thanks everybody. Cheers.